Hey guys, I hope that I'm live right now. If you guys are able to listen me properly, as well as there's no issues with the audio or the video, please let me know. There might be certain lag with my video, guys, but do ignore it because I'm not having my camera right now, so I'm just traveling. This is a makeshift camera that is currently present. So if there is any kind of lag with my video, okay, with my video, then just leave it alone. Okay, it's not that important. What's important is that the screen should be not lagging. Okay, if I'm lagging a little bit, it's fine. The screen should not be lagging, guys. Please do understand it. Okay. Okay, guys. So how was your day? How was your day, guys? How was your day? How was your day, guys? Was the day good? Was the day good, guys? Superb. Nice. Okay, great. Awesome, guys. Awesome. So let's do a quick revision about what we have studied in our previous class, guys. Could you guys let me know what have we studied in our previous class? Could you guys let me know what have we studied in our previous class, guys? Just a quick revision. Could you guys let me know what have we studied in the previous class, guys? We studied about pointers, right? We studied about pointers yesterday. Anything else that we studied in our yesterday's class, guys? Anything else that we studied in our yesterday's class? We studied about how to create 3D arrays as well. That's good. Anything else, guys? Anything else? Finding the largest element in an array. Good, great, awesome. Okay, so that is something that we studied in our yesterday's class. From our today's class, we're going to start out with our new data structure, that is linked list. We'll try to understand what is linked list, how to create linked list inside of your C++. Okay, that is something that we'll be seeing in our today's class, and I hope that it is going to be pretty fine and easy for you guys. It should not be that difficult for you guys to understand. Okay, so shall we start with our today's class, guys? Please let me know. Shall we start with our today's class, guys? Please let me know. So the webcam might be lagging for you guys. Just ignore it because I am not at home. I'm currently traveling, so this is the best that I can do with the camera. So just ignore it for a while, guys. The video, that is the screen share that I have done, as well as my audio should not be lagging. That is the main part. Okay. Okay. Great. Awesome. Let me select everything and delete everything right over here. So up till now, we have studied about arrays. If you guys remember, whenever we create an array, you are having the entire array in contiguous memory locations. For example, we know that this is an array of numbers. This is an array of numbers or an array of integers itself. Each of this integer will take up 4 bytes of space, guys. Each of these integers will take up 4 bytes of space. But nevertheless, guys, the addresses at which these numbers are now stored are basically present at contiguous locations, right? For example, this, if the address is like 00FX545, then this will be stored as 00FX549. And then this will be stored as 00FX5 5, 3, and so on and so forth. So as you're able to see, the numbers that are stored inside of an array are stored contiguously. It is not stored separately. All of the numbers will be around the same address itself. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know. So that is what is meant by our arrays. Okay, these are the ARRAYS, guys, arrays. Okay, please try to understand this, guys, that your linked list challenges this particular ideology, that why do we need to store our particular stuff at the same location. This might cause a lot of different errors at any particular point of time, and a lot of wastage as well in storage of stuff. So what LinkedIn, sorry, it's not LinkedIn, linked list says is that I will not store these at contiguous memory locations. I will store these at individual memory locations itself. For example, this is my particular number, okay, 4, and the next particular value I'll be creating a pointer that will be storing at another particular location. That is, let's assume this is the next number, then this will be pointing out to some next number, and so on and so forth. So I want to draw it out properly itself. It will look something like this: 1, then a pointer to the next number. This is 2, then a pointer to the next number. Then this is 3, then a pointer to the next number. 4, then a pointer to the next number, and then 5. Now here, each of the element that we are having has two particular values associated with it. Each of the number that we are having have two particular values associated with it, guys. The first value is data, and the second value that is stored is the address of the next value, or a pointer to the next value, guys. Are you guys able to understand this? Each element that is stored within our linked list contains two values. The first is the data itself, that is the element that you want to create. And the second is the address or the pointer to the next particular element. So in this, your data need not be contiguous. Okay. In this, the data need not be contiguous, guys. For example, right over here, we are having 1 and the address as 00FX54. Okay, so this is stored at 00FX09. So 00FX54 is somewhere located at a very different position. This is 00FX54. 00FX54, guys, where 2 is present. Now this will store 00DC1. 01. Okay, 00DC01. Now that will be present somewhere here. 00DC01. Okay, this is where your 3 is going to be present, and then the next. So what is happening is you're creating a pointer to the next particular value. That is what you're doing. You're creating a pointer to the next particular value, where the next particular value is actually present. Okay, are you guys able to understand this? Please let me know. Are you guys able to understand this, guys? Please let me know. Now, each of this pair of values that you are able to see, where there is data and the pointer PTR to the next particular value, is also called as node, guys. It's called as node in a linked list. Okay, this is what we refer to as a node in a linked list, guys. And this is called a singular or a linear linked list. Okay, this is also referred to as a singular or a linear linked list, guys, where there is a single way in which we are arranging the numbers. Okay, we will learn about other types as well. There are doubly linked lists, there are circular linked lists, and so on and so forth. This is what is called as a singular linear linked list. Okay, pointer is something that we have learned in our previous class, guys, so I don't need to tell you guys what is a pointer again. We have learned it in our yesterday's class. Okay, singly list linked list or singular linear linked list, all these are different names for this type of linked list, guys. Now creating this linked list is something that is new for us. Okay, why? Because up till this point of time, for example, arrays, when we were creating it, we were directly using the array data structure itself, ARR, and then parentheses right over here, and we were able to create our own array. In this particular case, we are going to create our own data structure from scratch. This is not present inside of C++, guys. We are going to create our very own data structure that is going to be the linked list, that is going to create our linked list. Now the smallest unit of our linked list is basically this node. Am I right, guys? The smallest unit that makes up the entire linked list is basically node. Am I right or wrong, guys? Please let me know. Krishna, I think so. You are late in today's class, hence you're not able to understand it. Please watch the entire video from the start. You will be able to understand it. Okay. The smallest unit of a particular linked list is basically node, guys. So, and we need to create a structure, a data structure that basically creates these nodes for us, guys. That is where we are going to start in our today's class. That is where we are going to start in our today's class, guys. We are going to create our very own data structure. So our job is very simple. We are going to take in an input of a particular array. I'm so sorry. We are going to take up an input in the array. Okay, ARRAY array. That is going to be our input, guys. I'm going to convert it into a linked list. We're going to convert it into a linked list, guys. Okay, that is our aim. We're going to convert a contiguous memory allocation data structure into a non-contiguous data allocation structure, guys. Okay, it is from an array to a linked list. That is as simple as that, guys. Let us go back to our website. Let us open the coding arena right over there. What is node? So I think so I've already explained to you guys what is node. Okay, I've told you guys what does a node contain. Now it is asking the exact same question. What is Faraj Muhammad? You are Faraj Muhammad, right? It's a name given to you. What is node is exactly like me asking what is Faraj Muhammad. You will say I am Faraj Muhammad. In a similar manner, this is what the node is. I've explained that it contains a data and associated with it the pointer to the next particular element, which can exist anywhere inside of the memory. It need not be contiguous. It need not be that, okay, first element, then second element, then third element inside of the memory allocation. If you have not heard about me speaking about memory allocation in the previous classes, then you will not be able to understand it. Okay. Okay. So right over here, guys, let us open up C++ online compiler. Won't the memory required be more? Absolutely, yes, Mohammed. That's absolutely clear, because if we are creating an array of 6 elements, to make the exact same thing instead of linked list will require 12 memory spaces, because one for the data and one for the pointer. But inside of arrays, you can only create fixed size arrays itself. It can only be of 8 characters long, 100 characters long, and so on and so forth. But in the case of linked list, you are not bound by that. You can create a linked list of just 2 characters if you want. You can create a linked list of just 101 characters if you want. And all of those will be occupied. You don't have to waste unnecessary space when it comes to linked list. Okay. Okay, let us try to do that. Okay, the first thing, guys, instead of using include IO stream, what are we going to use? Instead of using IO stream, guys, what are we going to use? Again, for many of you guys who are saying that the video is lagging, I'm currently traveling a little bit. Okay, so I don't have my my camera with me. This is a makeshift camera that I'm currently using. So that is the most that I can do. The audio is more than sufficient and the background is working absolutely fine, so you don't have to worry. If you are having a lot of problem with my video, then I will just remove my video from my screen, because that is not important. Okay, even if the video is lagging, that is just my video that is lagging. The background is working absolutely fine, the audio is working absolutely fine. So focus upon your studies right now. For those who have come in late, if you are putting up this particular question that it's lagging, that means you are coming in late, because I've already told this in the start of the class. Should I just cancel your attendance for today? I don't think so, right? So focus upon the class itself. Great, guys. So bits /stdc++ .h. Amazing, guys. Bits /stdc++ .h, guys. Okay, great. And then using namespace std. Okay, these are the two things that we will be doing right over here, guys. The next thing that we are going to do right now is that we are going to create our new data structure that is going to be called as node. Okay, that is the smallest unit that we need to create our linked list, guys. Now creating that is going to be very simple. We need to create a structure called as node, guys. A structure called as node. Okay. So struct, struct. Okay. To create a structure, a data structure, we just write a term struct itself. That basically means structure we are creating right over here. The name of that structure is node node, and then you are having your parenthesis. Now what does this particular node actually contain? Okay, what does this particular node actually contain? So if you're creating this structure node or you are using this structure node, what are the two things that a structure contains, guys? Please let me know. What are the two things that this structure contain, guys? Can somebody let me know? What are the two things that a node needs to contain, guys? Please let me know. It needs to contain the data, right? The value that is there, and the pointer pointing to the next particular node. It needs to have two particular values, the data and the pointer pointing to the next particular node, guys. So we'll declare that this particular node, whenever you're creating it, has two particular things. That is int data. There's going to be the data that you're going to store inside of it, and a node star pointer, because it is pointing to the next node, guys. Please do remember this. The type of this pointer should be node, because you are pointing to the next node, not to the next element. You're pointing to the next node, guys. So node star next. Name of our pointer, we are naming it as next, guys, because it is pointing to the next node. Okay, are you guys able to understand this, guys? Please let me know. Are you guys able to understand this? Please let me know, guys. Are you guys able to understand this, guys? Please let me know. Now here you have created a blueprint of what this node looks like. Okay, you have created, this is a blueprint, guys. That okay, this is a particular, I'm making a drawing that okay, a node will contain some data and a node pointer to the next particular node itself. I've created that. But how can I create this node? How can I create? This is just a particular definition. Okay, but I need to create this node as well. To do that, we need to create another structure, guys. Struct struct. Okay, another structure of node star new node int data. So what did just happen right over here? So what we're doing is we are creating a new method inside of our struct node, guys. Inside of the structure node, we are trying to create a new method right over here, guys, called as new node. This new node method is going to be provided. Okay. This new node method is going to be provided with a new data. This is the data that I want inside of the new node itself, guys. Okay, new node is the name of this method, guys. New node is the name of this particular method. I'm creating a new node right over there, guys. I'm creating a new node right over there, guys. Okay, this is a new method, a new function that I'm creating that will help me create a new node. As the name suggests, it will help me create a new node itself. एक नया नोड बनाने में तुम्हारा हेल्प करेगा. Are you guys able to understand this? Please let me know. Inside of this struct node, inside of this structure node, I want to create a new method called as new node, which will help me create a very new node itself. Yes. So right over here, guys, the first thing that we're going to create is how to create a new node. Okay, that is the first particular question that most of you guys are going to have. To create a new node, it is very simple, guys. Node star node, that is the name of the node itself, is equals to new node. Now, many of you guys will be having a lot of different questions right over there that what did just happen right now? What did just happen right now itself? This looks something very different from what we are trying to do, right? This looks something very different from what we are trying to do. This is how you actually create a new node. Okay, you use that, okay, what is the data type that you are trying to create? Here the data type is node. Okay, here the data type is node, that I'm trying to create a node itself. What is the name of that node? The name of that node is node. Let's name it as Shaurya right over here. Okay, the name of this particular node is Shaurya. And to create Shaurya, you use this new term. You create this Shaurya node. So Shaurya is a node. Okay, Shaurya is a pointer to a node, guys. Basically it's a node. It's a node, guys. I'm creating a new node right over here. New basically creates a new object. New term right over here creates a new object that helps you create a object of a type node. It basically uses the blueprint of node. It usually uses a blueprint of node and actually creates a building out of it. Are you guys able to understand this? This new term uses this particular blueprint and creates a building out of it. So basically it creates a new object of the type node itself. See, this is something that you need to understand. Okay, this is something that you need to understand, guys. You need to understand this, guys. So right over here, you're creating a node called as Shaurya. You are creating a node called as Shaurya, guys. And to create that, you're creating it as a new object of type node. Creating it as a new object of type node, guys. I am able to understand it is very confusing for many of you guys, but just listen to me very carefully. Here you have created a particular blueprint. Here you have created a particular blueprint, guys. Okay. Now you are creating a function that helps you create new nodes. It assigns the value right over there. It creates the node, everything. So if I want to create a node that has the value of 10 inside of it, how can I do that? How can I do that? The first particular step will be creating a building, an empty building, let alone it be an empty building itself. The first step will be creating a building using this particular blueprint, creating an empty node using this particular blueprint itself. That is what we have done right over here. Node star Shaurya is equals to new node. That is what we have done right over here, guys. The next particular, see, it's not too difficult to understand. Pallavi Patil, it's not at all difficult to understand, guys. You are creating a function. Okay, I will just remove my particular video from the screen itself. Keep my video right over here, guys. Otherwise, without the video, you guys won't be able to listen to me properly. Okay. I'll have to keep the video right over here, guys. Without the video, you will not be able to listen to me properly, guys. So please pardon me for the same, but the video is going to be there. Okay, are you guys able to listen to me right now? Are you guys able to listen to me right now, guys? Please let me know. Are you guys able to listen to me right now? Please let me know, guys. Don't focus upon the video, just focus upon the audio. Okay, don't focus upon the video, just focus upon the audio itself, guys. So right over here, we are having a node. Okay, we are having a blueprint right over here. This blueprint helps you create a particular node. It tells you that, okay, this is how the node is going to be created. You are going to have a data and you are going to have a pointer. This blueprint for you is called as node, struct node. This blueprint is called as struct node. It gives you a blueprint on how to create the node. Now you want to create a particular gun. You want to create a weapon in which you are able to feed in a particular value. For example, 10. You are able to feed in a particular value, and as soon as you press the trigger, it will give you a node which contain the value 10 inside of it. It will give you a node to actually use which will contain the value 10 within it, guys. That is what you want to create. So first of all, what is this function returning back to you? What is this particular function, this particular gun giving back to you, guys? Please let me know. What is this particular function, this particular gun giving back to you, guys? Can somebody please let me know? What is this particular function or this particular gun giving back to you, guys? Come on, guys, please be fast. What is it giving back to you? It is giving back a particular node. It is giving back a structure called as node. That is what it is giving back to you. Struct star node. This is what is being returned from the function. This is what is being given out of the gun itself. Now, what is the name of this function? What is the name of this gun? The name of this gun is new node. The name of this gun is new node. And what does this particular function take in as an input? What does this particular function take in as an input, guys? It takes in the value, that is int data. It takes in the value as an input, guys, that is int data. That is how you declare a function. Now this is what the function return back to you. What is the name of the function? What does the function take in as an input? Now we need to create the code for us to do all this. We need to create, this is how you declare a function. Now you declare what does the done do. Now what exactly is its functionality inside of it? We'll have to code it. What is the mechanism? We will have to code it. The first particular thing is we need an empty. To create this, we need an empty node. How to create this empty node, guys? We need an empty node. How to create this empty node? So node star, it is of a data type of node. It is the data type is node, guys, not integer, not anything. It is a data type node, guys, for which we are creating a pointer called as Shaurya. This is our new node. This new node is going to be called as Shaurya, guys. So this is basically this. Okay, Shaurya. We are creating a pointer to this new node. We are creating a pointer to this new node called as Shaurya. And to create that, it is equal to using the new term. New will basically create a new occurrence, a new object of the type node. Using the blueprint node, guys. Using the blueprint node, we are able to create a new object or a new occurrence of node, guys. And we are naming that as a pointer to that particular node as Shaurya. Is it similar to constructor? Absolutely yes, guys. We are actually learning about constructors itself, but in a little bit more depth. How does a constructor work? That is what we are trying to understand. Now that you are having an empty, now that when you are having an empty node itself, you need to fill up with the values of data and the pointer. These are the two things that you need to do. The pointer is called as next. The pointer is called as next, guys, and the value is named as data as mentioned inside of our structure. That is our struct node, guys. The blueprint, it is named as data and node. So this is called as node, guys. Again, next, sorry, N-E-X-T, next. Okay. So to access that, guys, it is very simple. Within our Shaurya, we want to access data is equals to data from right over here. Similar to that, Shaurya next is equals to, right now there is no next particular value, guys. Hence we are going to name it as null. that this particular pointer is actually pointing to the value null, guys. Null is nothing. In C++, null means nothing, guys. Null means nothing. There's nothing right over there. But right now, just to create this particular thing, we are putting up that. So Shaurya data is equals to data, that is 10. And the next particular value is pointing out to be null, guys, right over there. And we are going to return Shaurya back to us. Why are we returning Shaurya? Because we are returning struct star node back. We are returning struct star node, guys, or struct node star. Sorry, struct star node not. I'm very sorry for that. Struct node star. That is a pointer to the node. Okay, the pointer to the node itself, guys. I know it's a bit complicated. Let us look that from this particular point of view, guys. Right over here, we'll be having Shaurya data is equals to data. If you're not comfortable with this, guys, you can remove this and put it up as value. Then we can shift this as a value itself so that you guys are easily able to understand. So whatever value that we are taking in, that is 10, that value is getting assigned to the data of node, that is Shaurya. In a similar manner, Shaurya next is equals to null, and then we are going to return Shaurya back to us. That is how we create our node, guys. This function will help you create node every single time. You don't have to do it from scratch every single time. This will do it for you. Are you guys able to understand this? Please do let me know. Are you guys able to understand this, guys? Please do let me know. So right over here, if I want to create a new node at any particular point of time, let's assume, so node star head is equals to new node, or sorry, new node, I think so I have to keep it together. New node, hope so I've written it correctly. Okay, and it's capital right over there. Keeping the name similar is very important, guys. So here new node is very important. So I'm keeping it as new node, and then let's assume 10. Okay. So, and then we'll create another node, guys. So this 10, right now what we have done is we have created a node. Okay, we have created a particular node, guys. So here we have created a node that has the value 10 inside of it, pointing to null, called as head. This is what we have done right now. Okay, this is what we have done right now, guys. We have created a node called as head right now. That is what we have done right now, guys. Now we'll create another node, guys. So node star temp 1 is equals to new node 20. Node star temp 2 is equals to new node 30, and then we are going to put up head next is equals to temp 1, temp 1 next is equals to temp 2. Let us try to understand. Didn't understood whatever you have written inside of struct node. What are you not able to understand? It is basically me defining you as so where are you? Sanya Jain. Okay, Sanya Jain, who are you? Okay, Sanya Jain, who are you? You are having an upper body and a lower body. These are the two parts associated with you. You are a human being. You are having an upper body and a lower body itself. In a similar manner, what is a struct? Okay, what is this struct node? What is this new data structure node? What are the components that it has? It has a int data, that is the data that it contains, and node star next, that is the particular node that it contains. Okay, a pointer to a next node that it contains. So that is a pointer to a node, guys. Pointer to the data type node, that is called as next. Now these arrows are how you basically access the data and next values from your particular node. Okay, your node data structure is there. How can you access the data? And next from that, that is what you do using these values. Okay, very simple to understand, nothing too complicated about it. So right over here, guys, what have we done right over here? That is something that we need to understand. So this is called as the head pointer. We have then created our next two pointers, guys. So the next pointer that we have created right over here is 20 null, and this is temp1. Then you are having 30 null, temp2. Okay, these are the three things that we have created right over here. Okay, this is what we have done right over here, guys. Node star head is equals to new node 10. Node star temp1 is equals to new node 2. I don't understand what does the arrow means. So Krishna Molle, for example, I will point it to you guys. You Krishna Malode. Okay, that is what is happening right over there. You are pointing out the particular container that is called as data that is present within the structure. The structure has two buckets inside of it called as data and a particular next pointer. You're pointing it out that inside of this node, this particular thing that is present, this particular container that is present, it is just a particular, like, okay, this particular value, that is all that is there. You don't have to think deep inside of what is this arrow, why this arrow. You know that that particular structure contains a data and contains a particular next value. You are trying to access that value itself, and that you access using this particular arrow. For example, head, it contains the next. You are pointing that out that, okay, this particular value that is contained of next is now equal to temp1. So next points now to temp1 itself. So this is what we have done right over here, guys. So node head, we have created our head temp1 and temp2, as you're able to see right over here. We have created that, guys. The next particular line of code is saying that nodes, the next particular line of code is saying that head ka next is equal to temp1. Head ka next is equal to temp1, guys. So we'll go back. Head ka next is right now equal to null. Head ka next is right now equal to null. Okay. Sir did not understand struct node star. What is node star? Is it a new data type that we have created and calling it as new node? Absolutely wrong. So struct node star. So struct node is the new data structure that we have created. Yesterday we have learned about int star, right? That is basically an particular pointer to a particular data type called as int. Here the data type is struct node, and star basically points out that we are creating a pointer to a structure called as node. This is a pointer. New node is basically a pointer. So as we are able to see, head is a new node, right? What is it? What is head, guys? Please try to understand this. What is head? Head is just a pointer. It is nothing else. You are creating this new node right over here, guys. Head is nothing else but just a pointer to a structure called as node. It's just a pointer to a structure. And right now you are writing this particular line of code that is head next is equal to temp1. So instead of now it is being equal to null, we're going to remove that. Now it is no longer going to be equal to null, guys. Now it is going to be head ka next is equals to temp1. Similar to that, the next particular thing right now, is temp1 ka next is equals to temp2. Temp1 ka next is equals to temp2, guys. We'll again go back. Right now it is equal to null. We are going to change that. Draw, erase, draw. Temp1 ka next right now is going to be temp2, guys. Okay, it's going to be temp2. To be very specific, actually, if you want, is actually going to be this. Okay, this is going to be equal to this particular pointer. This is going to be equal to this particular pointer, and so on and so forth. And so on and so forth, guys. That is how you are able to create a linked list. I know it is a lot, guys. Try to take some time today. Try to understand this because this is very important for us. Okay, try to take some time. Try to understand this, guys, because this is very important for us. Otherwise, I won't be focusing upon it a lot. Okay, spend some time today to understand this, guys. Temp2 connects is null, guys. Temp2 connects, we are not changing it inside of our code. If you see within our code, where have I changed temp2 connects? Temp2 connects, whenever it was created, was declared as null. If you guys remember inside of a picture as well, temp2 connects is currently null. We have not changed that. Null has no value. It is not equal to zero and anything. Null is basically nothing. That is it. Null is not zero. Zero has a value. Null is basically nothing, guys. Nothing out there. Okay. It is not at all difficult, guys. Try to give a little bit time today to understand the topic a little bit more, guys. Rewatch the video. Try to write the code yourself. Try to understand it yourself, guys. Is null a garbage value? Absolutely not. Null means nothing. No value. Null means nothing. No value. It is void, just like space. Space is nothingness. Space is nothingness. Similar to that, null is also nothingness. There is no value to it. Okay, right now I'm giving you guys the attendance. Please start filling up the attendance right now. The attendance link will be closed exactly at 9:02. The attendance link will be closed exactly at 9:02. Please start filling up your attendance. The attendance link will be closed exactly at 9:02, guys. Please start filling up your attendance. Yesterday there were two attendances, so those who have missed out on the second attendance, I'm very sorry, but you have got zero attendance from yesterday. Okay, those students who have don't know, I'm telling you guys right now. Yesterday there were two attendances. If you have missed out on any of the one attendances, then you have missed out on yesterday's attendance. It is zero for yesterday. Okay, the attendance is there in the live chat, guys. Please make sure that you guys are able to fill up the attendance on time. We'll meet in tomorrow's class and we'll continue from right over there. Thank you so much, guys. Thank you, guys. Bye, guys. Bye.